Good morning. Today we're going to continue on with our lesson yesterday, solving linear systems, but we are going to do it by multiplying first. So yesterday we reviewed over how to do solve linear systems by the elimination method, or also known as the linear combination method, where we combine two equations to eliminate a variable, and then we can solve for one, substitute in, find the other, and then we have our ordered pair solution. Today, however, we're going to look at some equations where we might need to multiply one of the equations or both of the equations by a number or some value to get the variables to cancel. Just as a reminder, we want to make sure that all of our equations are in standard form before we attempt to cancel out any variables. So looking at the first system that we have here, we have 3x minus 2y equals -4, which is in standard form. The x and the y are on the left, and the constant is on the right. The second equation is also in standard form. The x and the y are on the left, the constant is on the right. So far we're set up pretty good. Now, normally what we would do is we would try to add up these two equations. But if we add these, we get a 10x and then a -6y, and neither variable cancels, so we're kind of left with a problem. The whole idea of this method is so that something is eliminated or canceled out. So then we have to kind of ask ourselves, well, is there some way that we could get either the y's to cancel or the x's to cancel? So is it possible that 3 goes into 7 a certain amount of times? Maybe I can just make that 3 into a -7. Or what about the 2? Does the 2 go into 4? Maybe I can just make that a 4. So we notice that 3 does not go into 7 evenly, but 2 does go into 4 evenly. So if I multiply this equation here by a -2, that will in turn make this -2 into a positive 4y, which will then cancel my -4y. So that's what we're going to do. So I'm going to take this first equation, I'm going to multiply everything by the -2. So make sure that number gets distributed to all three parts of that equation. So we end up with -6x plus 4y equals +8. Then the second equation, we can just recopy it as it is because we're not changing anything to that one. Now, if you've chosen the right number and you've distributed successfully, one of your variables should now be eliminated when you go to add up these two equations. Okay, so step one, we multiplied one of the equations so that we got something that would cancel. 2, we're now going to add these equations. Our y's here are going to cancel because we have a positive and a -4y. And now we're going to add what remains. So -6x and 7x give us a 1x. 8 minus 6 equals 2. And luckily for us, we don't have to do much more there because we already solved for x. Now the third step is the same as we've been doing with both the linear combination elimination method or the substitution, and that's when we just substitute in this first variable into one of our equations, so it can go into either one of those, and then we're just going to solve for the y. So I'll just use the second equation. I have 7x minus 4y equals -6. I'm going to put in that 2 for my x. 14 minus 4y equals -6. Subtracting my 14, I have -4y equals -20. Dividing by the -4 gives me a y equals +5. So my final solution here is going to be written as that ordered pair, x comma y. So I have 2 comma 5 as my solution. And then under here you can see if we were to check, we would substitute the 2 in for the x and the 5 in for the y and make sure that both equations do work out with a true statement, and that would confirm that your answer is correct. All right, so let's do a few of these. So the first problem here, we have 15x plus 4y equals 25. It is in standard form, so that's nice. And the second equation, 5x minus 3y equals 30, is also in standard form. So we've got that going for us. So at this point, we really want to find a way to cancel either the x's or the y's by multiplying to make them the same. So 4 doesn't go into 3, 3 doesn't go into 4, so we could multiply both rows by a number, but if we look at the first part here, the x's, if I multiply a 5 by a 3, that'll give me a 15. Now that's good. However, in addition to the numbers being the same, having the same coefficient as far as the value is concerned, we want one to be negative and one to be positive so that they can cancel out. So I have to actually distribute a negative 3 to my second equation so that I can get a negative 15 when I distribute, and that will get the two x's to cancel. So negative 3 times negative 3 gives me a positive 9y, and negative 3 times 30 will give me that negative 90. And of course, the first equation doesn't need to be changed at all, so we're just going to recopy it above the other one. And now we can just simply combine our two equations and eliminate that first variable with the 15 and the negative 15. So now I end up with 13y equals negative 65. And I divide by 13 and I get y equals negative 5. Okay, same as always, we would then take our first answer and substitute it into one of those original equations. Either one is fine. They will both get you the same value for x. So I'll just do this one here. The numbers are a little bit smaller. So 5x minus 3 times y, which we just figured out was negative 5, equals 30. Negative times negative is a positive 15. Subtract, because you want to get that x by itself. And divide, and we get x equals 3. So then we write our ordered pair solution, making sure your x value always comes first and your y value always comes second. All right, so moving on to number 2, before we can really do anything for number 2, I'm noticing that my second equation is not in standard form. So the first thing I want to do is I'm going to rewrite the equations to make sure they're both in standard form. Now, number 1 is already in standard form, so I'm just going to leave it the way it is. 5x plus 3y equals 18. My second equation, however, the x is on the wrong side. So to be in standard form, my x needs to be on the left and it needs to come before the y. But anytime you move something to the opposite side of the equal sign, you're going to change the sign. So this is going to become positive 7x plus 9y equals 6. Okay, so now that they're both in standard form, we want to look at the two equations and see, is there something that I can do here to get something to cancel? So I have a 5 and a 7. Those are not going to cancel. I have a 3 and a 9. Those are not going to cancel. However, 3 does go into 9 evenly 3 times. So if I multiply this first equation by 3, 3 times 3 will give me that 9 that I need. However, this is a positive 9, so I need to make mine a negative 9. So I'm going to do that by multiplying everything by negative 3. That's going to give me negative 15x, negative 9y or minus 9y, and then 3 times 18, which is negative 54 because it was a negative 3. The second row is just going to get recopied the way it is. And now I'm going to add up my two equations, eliminating my 9y and my negative 9y. So now have negative 8x equals negative 48. And then I can finish solving for x by dividing by negative 8 and getting x equals 6. Of course, then you just substitute into any one of those original equations that you had, doesn't matter which one. So I'll just use that one that's highlighted there, but you could use any of them. It doesn't really matter. So since this one already has the y somewhat by itself, I just feel like that's going to be a little bit easier, but it doesn't matter. Any of them would work. So negative 7 times 6 is negative 42. Negative 42 plus 6 would be negative 36. And then I divide by the 9. And that's going to give me y equals negative 4. So then my ordered pair solution, with the 6 being my x value coming first and the negative 4 as my y value coming second. All right, and one more. All right, so again for number 13, number 3, we have two equations. Both of them need to be rewritten in standard form. So that's the first thing I'm going to do. So in the first equation, the y here is on the wrong side, so I need to bring that over to the left, which is going to make it a minus 7y. But the 4x and the 14 stayed where they were. Then on the second equation, I'm going to bring my 3x over, making sure it goes in front of the y, and it's going to become a negative 3x. So that's the first thing we have to do. All right, once they're in standard form, we now need to see, is there anything that will cancel out when we add them up? 4 minus 3 is going to give you 1, not going to cancel. Negative 7 and 14 is going to give you 7, not going to cancel. So now this is where we want to look for, well, what will make these cancel? So I know 7 goes into 14 evenly. So I could multiply my negative 7 by a 2, and that will give me a negative 14, which will cancel then with the other 14. So we're going to multiply here everything by 2 in this first equation. That's going to give me 8x minus 14y equals 28. And then the second equation is just going to stay the same. I'm just going to recopy it so that the like terms are all lined up. Now we can add together our two equations because our y's will be eliminated. 8 minus 3 is 5x. And over here, 28 plus 7 is 35. And now I can easily divide by 5 and solve for x, getting 7. Plugging that into any one of those original equations, whatever one seems better to you, right? So since I'm going to solve for my x, I'm going to use this first equation here. So 4x equals 7y plus 14. Subtracting the 14 so we can get the y by itself. And then finally dividing by that 7, y equals 2. My final answer as an ordered pair would be 7, 2. Okay, so moving on, we're going to do another example, but this time we're going to have to multiply both equations before we can combine them. So we'll notice here, solve the linear system. Now, the first one, again, just as a reminder, all of these, if you're using this method, all the equations need to be in that standard form with your x and your y on the left, your constant on the right. So we can see the first equation here is already fine. We have the 5x followed by the 2y and then the negative 18 on the right side of the equal sign. However, equation 2, the x is on the wrong side. It needs to be moved over to the left, which will make it a negative 3x. Then you have your plus 7y equals your 19. Okay, so as always, step 1 is to arrange the equations so that the like terms are in columns and they're in standard form. Now, step 2 is going to be doing any of that multiplying that needs to happen. So if we look at these two equations here, we can notice that 5 and 3 are not going to cancel out. 2 and 7 are not going to cancel out. So we could multiply the 5 and the 3 by something, making them into their least common multiple, which would be 15. Or we could multiply the 2 and the 7 by something, making them into their least common multiple, which is 14. But how do you choose? It doesn't matter. You really have the option of doing it either way. You should get the same answer in the end regardless. However, I would probably choose to do the 5x and the negative 3x because their signs are already opposite. When you already have opposite signs, that's one less thing you have to worry about. You don't have to worry about distributing a negative to anything. So we're going to multiply this row here, the second equation with the negative 3x, we'll multiply by 5. And the top one, we're going to multiply by 3, and that will give us a 15 and a negative 15. So again, make sure you're distributing to all three parts of that equation. So 3 times 5 is 15x. 3 times 2 will give me 6y. And 3 times negative 18 is going to give me negative 54. The second equation, 5 times negative 3 is negative 15x. 5 times 7, 35y. And 5 times 19 is 95. Now I can go on to my step 3 where I'm going to add the two equations. Of course, my x's are canceling because I just multiplied them in such a way that those two would be eliminated. 6 plus 35 is 41y. Negative 54 and 95 gives me 41. And that's going to leave me with y equals 1. Then once we solve for that y, we can plug that y in or substitute 1 for y in either of those original equations and solve for x. So whichever one you want to use, it doesn't matter. It's really completely up to you. I'm going to do the first one since there's no negative on the variable, but there's really no rhyme or reason. I'm putting in that 1 for the y. So we have 5x plus 2 equals negative 18. Then I would subtract that 2. So I have 5x equals negative 20. Dividing by 5, x equals negative 4. And that is where they're coming up with a solution over here. The ordered pair is negative 4 and positive 1. Of course, as always, if you're especially taking some type of assessment, you want to check your answer, make sure it's correct. This solution would have to be true for both equations. So you could substitute the negative 4 for the x, the 1 for the y, make sure they work out. They both do. And then you know for sure that that is correct. All right, so we're going to do couple practice on the multiplying both equations. All right, so first thing, number 4, they're both in standard form already, which is nice, right? So we have equation 1 in standard form, equation 2 in standard form. So what do we need to multiply these by to get something to cancel? Now, again, 9 and 12, right? What's my least common multiple there? I believe it's 36. So I could do 9 times 4 and 12 times 3 and get two 36s. That's an option. 5 and 7. My least common multiple there is 35. So I can multiply something there. How do I choose? Well, the 5 and the 7 are already opposite signs, and I just have to multiply them by the opposite number there. So I'm going to go with that. 7 times 9 is 63x. 7 times 5 is 35y. And 7 times 33, I believe, is 231. Okay, now on the second row, we're doing 5. 5 times 12 is 60x. 5 times negative 7 is negative 35y. And 5 times 3 is 15. Now we can add these up. Of course, the y's will cancel in this situation. So we have 123x equals 246. And we divide, and we get x equals 2. Substituting that into one of those original equations. So I'm going to use, I don't know, I guess I'll use the first one. So I have 9x, which is 2, plus 5y equals 33. 9 times 2 is 18. Subtracting the 18. 5y equals, I believe that is 15. And then we end up with y equals 3. So our ordered pair solution is 2, 3. All right, let's take a look at number 5. All right, so before we do anything here, we want to make sure that this one has two standard form equations. The first equation here is already in standard form. The second one is not. So the first one, I'm going to just recopy it as it is, 3x plus 7y equals 20. But the second equation, I'm going to move that 4y over. So now I have 5x plus 4y equals 41. Now I can focus on what am I going to have to multiply by to get something to cancel. Now in this case, we have 3 and 5 for the x's, they're both positive. 7 and 4 for the y's, they're also both positive. So in either situation, one of the rows will have to be multiplied by a negative number, and the other row will have to be multiplied by a positive number so that we end up with a positive and a negative of the same number. Now, whether you want to do 3 and 5 or 4 and 7 is completely up to you. So I usually just pick whichever ones are smaller. So I'm going to do the 5 on the top row, and I'm going to do the 3 on the second row. Now, again, like I said, because they're both positive, I need to make one of them negative. Doesn't matter if you want to do the negative on the 5 or the 3. I'm just going to do it on the 3. All right, so now I'm going to multiply here. So 5 times 3 is 15x. 5 times 7, 35y. 5 times 20 is 100. On the second row, negative 3 times 5 is negative 15x. Negative 3 times 4 is negative 12y. And negative 3 times 41 is 123, but it's going to be a negative 123. Now I can add these two up. My x's cancel, obviously, because I have a positive and a negative 15. 35 minus 12 is 23y. And 100 minus negative 123 is negative 23. Dividing, I have y equals negative 1. And of course, substituting it into whichever one you want to substitute into. So I don't know, I'm just going to do this here, this one. So 5x equals negative 4 times negative 1 for the y plus 41. Now I know a negative times a negative is a positive, so it'll be positive 4 plus 41, which of course equals 45. And then I divide and I get x equals 9. So my ordered pair solution is 9, negative 1. All right, and then the last problem for today. First things first, like I said, we want to put these equations in standard form. Okay, so this first equation, my x is on the wrong side. I need to move it over, and of course that's going to make it a negative 10x plus 9y equals 4. And the second equation, the y needs to move over, so I have 12x minus 5y equals 30. Okay, at this point, we need to decide what we're going to cancel. Am I going to cancel my y's by multiplying by 5 and 9? Am I going to cancel my x's, which I have options? I can multiply by 12 and 10, Or I could make them both into 60s. 10 times 6 is 60, 12 times 5 is 60, so options. Again, I usually like to go for the smallest one, so 9 and 5 are smaller. They're also both opposite signs already, so I can just simply multiply the top row by 5 and the second row here by 9. So my top row, when I multiply by 5, I'm going to get negative 50x plus 45y equals 20. My second row, multiplying by the 9, 9 times 12 is 108x. Then I have minus 45y, and then 30 times 9 is 270. Of course, my y's will cancel now. So I have, let's see, 58x equals 290. Divide by 58, and x equals 5. Substitute that into any one of your originals here. Doesn't matter which one you'd like to use. Since I'm going to try to get my y by itself, I think I'm going to do this equation here. So 9y equals 10 times x, which is 5, plus 4. That gives me 54. And then I divide by 9, and I get y equals 6. So my ordered pair solution is 5 for my x and 6 for my y. And that's it.